Good morning, and thank you everybody for coming to my talk. Wasm can do that, in which we're going to explore some of the areas that may not be as well covered in typically when you talk about WebAssembly in articles, in conferences. A little bit about me, for those of you that don't know me. I have been involved with open source and free software for a long time, since basically 1993. The term open source has not been coined yet. And mainly initially as a developer and writing documentation and books. And more recently as a founder. I co-founded Bitnami, which was a company devoted to packaging and making open source easy to use, and more recently of Wasm Labs, in which we helped in bring developers to WebAssembly from traditional languages like Python and WebAssembly. And really that has been the connecting thread through a lot of the things that I have done in my career. And it's been making technology accessible to more people, allowing developers and users to do things that they couldn't before. And that's exactly why I am excited about WebAssembly. Through the presentation, we'll have demos. We will show some of the things that WebAssembly can do. But for me, it's very important to understand why you can do this now with WebAssembly that you couldn't before. As a founder, you're always thinking about how to raise money, or if you need to raise money. And one of the things that investors look for is kind of like, it's called the 3 whys, right? Like, why are you doing this, right? Why this product? Why now? Meaning, what has changed in the world or in technology that allows you to do this, that you couldn't do this before? Why hasn't other founder or another company done this product before? And why you? Why this team? Why this particular founder? And it applies to WebAssembly. It applies to a new technology as well, right? Like if you are investing, air quote, your time, right? You're taking time away from work or your family to be here and learn more about WebAssembly. It's interesting to take into account why all the things that you're seeing here with the component model or AI or some other things that are happening that you couldn't do before WebAssembly. Although we are going to see these demos, through them I will try to explain what makes the fact that they are running on WebAssembly different. And talking about demos, the demo that started it all, and with ASM.js, as Chris just mentioned in his presentation, it was called the Citadel demo, which was the Unreal 3 engine more than 10 years ago. Running in Firefox, a tour through a medieval town with, at the time, like fantastic graphics. This is the demo that put in my head, or that put what eventually became WebAssembly in my radar, and got me really, really excited. And I promised demos, and we're going to do now a demo of the current state, or at least with Unity, of running games in the browser with WebAssembly, right? So this is like a wow, you're gonna wake up with the sound, but it's a fully feature, like 3D game, as you will be playing on a console or a PC, and it's running in the browser, and taking advantage of the distribution that you can get with the browser, while running at nearly native speed for all intents and purposes, and only taking like 180 megabytes, right, of memory. So I find that fascinating, that you can take like a game that was not specifically designed for the browser, and using, in this case, Unity, you can run it without modification and distribute it just by sharing an URL. And more recently, a lot of those engines support WebGPU, so you can the delta between the performance of running it on WebAssembly versus like a native desktop application that is accessing the GPU directly is narrowing and narrowing. And there is a lot of game engines out there that support WebAssembly. I mentioned Unity. There is other open source ones. There are actually open source projects that are porting the Unreal Engine, which unfortunately at some point dropped HTML5 and WebAssembly support, to actually run Unreal 5 applications directly in the browser as well. There is also other types of vendors like Rive that have an application that is not quite games. It doesn't allow you to create games. It allows you to create 2D animations and 3D animations that you can embed in other applications, like for training or education purposes. And we have talked about how you can port video games without changes or with minimal modifications to WebAssembly. You can also do the other way around. You can take WebAssembly and put it on your game. Since the early days of Doom and Quake, which people could extend the video games with Quake script and more recently on other games with Lua and custom script and languages, now you can do that with WebAssembly, and because you can compile a variety of languages to WebAssembly, then you can extend your favorite game with your favorite language. And the canonical example for this is Flight Simulator, where you can have really extensive, really high-quality modifications now done with WebAssembly versus compiling DLL, which has a lot of problems around stability and security. So it's really a win-win. There are a few talks related to this. Wonder, which is around how to create high-performance graphics for Wasm. Of course, XTism has a talk, a couple of talks actually, and is one of the most popular projects for embedding WebAssembly in your application. And if you squint a little bit, this is what you can do right now, but if you squint a little bit, 2-3 years down the road, and you realize now, what you can do of providing desktop-like applications in the browsers for games that you can distribute with an URL, you can start seeing how you can bypass things like the App Store, right? Like in order to deliver applications in the past, you have to be in the iOS or the Android App Store, or you have to do things like Steam, and this allows end users to directly access your game because they have, in most cases, their own UI and controls. You don't need a lot of the native platform to run, and you don't need any of the applications app stores that act as gatekeepers. So not only from a technical perspective allows you to run across many devices, you can also from a practical perspective, distribution perspective, allows you to be independent of the platform. Or you can do things like start streaming a video game in your console or your application, and then in the background continue to download it, and then eventually just sync the two and seamlessly continue to play. And that avoids the frustration that many of you have when you want to have a quick game and you spend 45 minutes just downloading updates and upgrades. Now, thanks to WebAssembly, because the same thing is running on the server than on your device, you can do that seamlessly. The next demo I want to do is around AI, and I was actually playing with this on the plane coming here. You can run, it's getting to the point where you can run high-quality LLMs in your browser. So this is running entirely in the browser, is being cached, the download, but everything else is running in the browser. And you can do things like, say, write a Python script that, and I'm going to make this on the fly, hopefully it comes up well, that scrapes or that watches the Hacker News front page and emails Daniel at example.com if Wasm.io, let's put it into quotes, or the word Wasm.io appears in a story. It takes a few seconds, but it finds the yeah, it's actually picking up the libraries that it needs, sending it to the email address that I say. It's able to detect that when I refer to Hacker News was news.ycombinator.com, and it seems that it's picking up, right? So you have this kind of copilot that you can now run in your browser without having to store anything, without having to read any script, without having to basically do anything just by accessing a URL. And it's not only it doesn't work for just text. You can run like scaled down models for image generation, like Stable Diffusion Turbo, and this comes from a project from Microsoft, in which you can tell it to display something. In this case, the sample is Paris with the river in the background. Since we're in Barcelona, let's say something like beautiful Barcelona sunrise on a March morning with the Sagrada in the background. And hopefully it doesn't let me down. Again, this is all running in the laptop using the CPU and the GPU. And it's not perfect, but it kind of looks like the Sagrada Familia. It kind of looks like Barcelona. And you can click, generate, and it will keep generating images, which I think is pretty cool. I mean, if you have been following what you can do with, hosted servers is not that impressive, but the fact that you can run this in the browser, and again, without having to store anything, is what, to me, is interesting. And then finally, you have another demo also as well from Microsoft, who has been doing like quite a bit of work here, in which you can run like segmentation algorithm, meaning that you can take any image that you want. This is the default image, and then you can point to parts of it, and it is able to detect and highlight objects. In this case, the pyramids, or the head of the cat, and things like that. And this is taking advantage of the web GPU. This is a Mac M2. But it always has a fallback mechanism. So you click on Wasm. It's going to take about 30 seconds to load. But you can run the same inference that you can without the acceleration. So it's a slightly not as fast, right? Slower. But yeah, again, the fact that you're running this without having to install anything, I think highlights some of the advantages of running this on WebAssembly, including the multi-platform deployment. For purposes of the demo, we saw it on the browser and leveraging web GPU, but there is other standards like WASI Neural Network, WASI-NN, that you can run in the server side, and you can take advantage of whatever the underlying hardware is in there, and processors, and can make it fast as well if it is available, or can make it at least run if it is not. And it doesn't matter if you're running this on a camera, or you're running this on a browser, or you're running this in the cloud. And we saw in the keynote by Midokura, it provides like a lot of advantages in terms of being able to deploy these vision applications or these inference applications where the data is. If you have a supermarket and the cameras are there, or you're on your phone and you don't have connectivity, you're still able to leverage a lot of this without having to change any of your code and taking advantage of whatever the underlying hardware is. There is also more interesting things popping up. The AI controller interface was just released a few days ago, again from Microsoft. They're doing a great job here. It's an open source project that allows you to provide prompts to some of these LLMs, and allows you to mold or make sure that the output conforms to a specific format, or allows you to, in a way, programmatically control the output of LLMs. And that opens a wall of possibilities for agents and other people that need to predictably use these models. There's a couple of talks around this from Wasm Edge, which have been doing a lot of pioneering work on the server side with AI. And there's an inference workshop, and also how to write extensions for LLM. as well as other talks around pipelets for vision AI using WebAssembly to extend and create filters and so on. And there is, I think, as well another talk with how you can use the Spin framework to run machine learning workloads. So there is a lot of interesting projects with WebAssembly and AI that go, way further than just a gimmick or just a proof of concept. I think they will be intertwined, right? The more that the devices that we have more CPU power, they start incorporating tensor processing units, the more than having like a common way of deploying to this variety of devices is going to be important. And that takes me to the next part. I don't have a demo for this. We wanted to have it, but it's just between the time and we have to do some hardware modifications to get it working. We didn't ended up putting the presentation. But you can take like a Raspberry Pi Zero, which was released about 7 years ago and costs like $5. It's this 32-bit device that it's like my thumb, and it can run WebAssembly, and it allows you, by using WebAssembly, to run. Back in the day with Wasm Labs, we ran like a complete modern JavaScript server-side stack on this tiny device. It wasn't the fastest in the world, but it allowed you to run, like I said, like a modern stack on like a really small, really cheap device. At least when it came out. Now it's because of the constraint in supply, is actually a bit more expensive, but it's still like very affordable device. You can run also in more recent versions of the Raspberry Pi Zero. I think that was released like 3-4 years ago, like the version 2. You can run like .NET on it using WebAssembly. So that means you can run WebAssembly in devices and bring a whole set of tooling, like the Midokura speaker mentioned, that give you a lot more productivity than having to use the vendor SDK for C and C++ and having to recompile for each one of these devices, which in many cases is not practical. And you can even run this on a Nintendo 3DS. Again, we wanted to show it, but you have to be rooted, and I couldn't get one. But you can you can really go down to microcontrollers and tiny devices. And the reason why this is important is I believe that we have going through a change of everybody for a while was just, as they should, center in the cloud. It provided a lot of new things that you could do by centralizing all the compute and making sure that you could get the same type of AWS instance on US East that you can get in Singapore, and allows you to automate and kind of industrialize a lot of the backend development. But now you're going to a world in which you have a lot of small devices that start to have significant compute power to start doing way more things, and those are very heterogeneous. There are different processors, different architectures, different capabilities, and Wasm can be like a really interesting abstraction platform that allows you to target many different devices without a lot of huge trade-offs in terms of performance, for example. I mentioned there are streaming apps because things like Prime Video and Disney Plus, they need to support a bunch of different TVs and streaming sticks and Rokus and things like that. And all of them have, or many of them have, adopted WebAssembly. Have rebuilt their applications on top of WebAssembly. So you only need to port once the WebAssembly runtime to these devices, and then all of a sudden, it makes it way more easier and to be targeting thousands of, in the case of Amazon, they mentioned 8,000 different devices or families of devices they need to support. It also, in some cases, is even if you wanted to use containers, you simply cannot use containers. You may be running on platforms that it's not only not running Linux, it's not even running POSIX, right? So being able to customize and adapt WebAssembly to that particular platform has a lot of advantages. And as I mentioned earlier, you can bring, you don't need to use whatever the vendor provided, right? Maybe an SDK that didn't updates since 1984 or something like that. You can actually have like modern tooling and run like modern languages on devices that typically you wouldn't expect that. There's a couple of talks around this. One is about running Wasm with TinyGo, which I'm really excited about, and also from Midokura on how to program those embedded vision sensors. And I think there are good showcases of what you can do today with WebAssembly. Let me show you first the demo about emulation, which we have been talking about how you can run WebAssembly in a number of platforms. This is more about how you can run those platforms like Linux or Windows on the browser, right? So this is like a full Linux machine that has been run boot. It's a smaller footprint Linux, 12 megabytes, but it's it is running Linux, and it's learning processes, and it's just like emulating an x86, right? So if you want to run Python, again, it takes a little bit of time, but you get the prompt for Python, and you can do things like import the platform, and you ask Python, where do you think you're running on? It returns an x86, because that's what we're doing here, is we're running like an x86 machine. And if you're running Linux, again, you can run Docker, right? So this will bring up a Docker container inside an x86 machine running on your browser. Is not tremendously fast. It is just an example that I pick up. There is a bunch of other companies working on the space. I'm particularly excited. I don't know if anybody from Leaning Tech here. They have been like excellent job, virtualizing Linux and things like Java and bringing applets to WebAssembly. And as well as a bunch of other projects like containers to Wasm, which allows you to take any container in the world running x86, ARM, or RISC-V, and turn that into a WebAssembly module that, again, you can run in the browser, you can do in the background. So we got a prompt, and we have a different file system, and if we take a look at the OS release, right, it's a container running Alpine Linux, and if we get out of the container, you'll see how here this is running like Arch Linux. So it's like a mini VM that you can run, again, just by going visiting a URL. And not only you can not only run Linux, is you can run any operating system, right? Or including Android or things like Windows, right? Again, it boot that sound. And if you feel nostalgic and want to run like programs, and you can now run Minesweeper and a Windows 98 running in your browser, right? So now that has a lot of practical applications, but it's interesting what it allows you to do, and what I think ultimately WebAssembly will be very successful, which is allows you to take what you already have, a lot of the platforms that you are familiar with, doesn't tell you to remove those, but allows you to incorporate them, right? So a lot of the work that is going on with component model, or all the work that went into the thought process of creating WebAssemblies, wanted to make it as universal as possible. And that means that you can emulate, or you can bring all these platforms where performance is not an issue, or previous generations of compute. You can bring those and play with them in the WebAssembly sandbox, or the WebAssembly runtimes, right? Just wanted to give also a shout out to Wally, in which we have mentioned here you can virtualize entire or emulate entire CPUs, there is another approaches that you can take, which is, in the case of Wally, is implementing the syscalls from the Linux kernel, and you can go a long way toward running unmodified Linux applications just by emulating the syscall and getting orders of magnitude more performance. There is a related talk, I think, tomorrow around how to compile generic Linux binaries directly into a WebAssembly module. I just wanted to make like a very quick reflection here. I used to work for big companies, and I mentioned a lot of this internally. I couldn't do it externally. Now I'm independent, so I can tell you how I really feel about Kubernetes. I'm really excited about things like a spin cube. Kubernetes is where we are right now as an industry, whether we want it or not. And it has a lot of good things for a lot of for very specific use cases of running at scale. The reality is most people are not running at that scale, and most people don't need the cost and complexity that comes with Kubernetes. And I wish there was a new platform that allows you to have the same or provide the same benefits that you can get from, say, running microservices in terms of modularity, in terms of scalability, isolation, security. And I firmly believe that WebAssembly is going to be that platform, or a platform based on WebAssembly will lead that, whether that's Fermion or Cosmonic or many other startups in the space. I don't know, but I hope and I believe that will be the future. And having things like a spin cube is an important first step of showing the rest of the industry what WebAssembly is capable of, and eventually run to WebAssembly without having or to need Kubernetes. And again, that goes to the spirit of WebAssembly and the WebAssembly community, that we go and tell people that you're idiots for running Kubernetes, you should migrate to this. It's like we meet developers and professionals where they are, which is you're running Kubernetes, you can make it better with WebAssembly. And there are like talks and workshops related to this as well. And finally, so we have a couple of minutes for questions. There's this quote by Peter Drucker, the management guru, saying that it's always difficult to predict the future, and one way of doing it, or the best way to doing it, is to actually build it and create it. And I'm really excited, and I'm really thankful for Sergi for putting together conferences like this. A lot of the people to creating that future, which, as you have seen, is WebAssembly, are here, are going to be presenting their projects, are in the audience, and are really like things that look like they have the first release right now, or they are kind of like in the proof of concept stage, will hopefully one day become mainstream. And I get a lot of the vibes of the first Linux conferences that I attended, or the first kind of like web conference that I attended, in which there was all these possibilities. A lot of them were things that didn't go anywhere, and some others, flourish into really mainstream projects that everybody uses today. So I'm really looking forward to the rest of the conference, not only for the talks but also for the people. Thank you for coming, and hopefully we have time for a few questions. Okay.
Somebody had to ask a question, and I guess it's me. Great talk, Daniel. Thank you so much. My question is, what do you think about the environmental implications of the extra computation that's needed to run something like WebAssembly? Or do you think it can be as viable as bare metal development as far as the amount of watts required for the computation?
Thank you. It's a really good question. I think there's going to be a panel on that, so probably people better informed than me are going to do it. My personal take is I personally don't worry about that. Once you have all these, countries building, to this day, like, coal plants every week and things like that, like the impact really of running WebAssembly in your TV, I think is important, but in the grand scheme of things, it's going to be negligible. And you can also, you can also make the counter argument, just the fact that some of that compute is running on your device, right? It means that there is a lot more data that doesn't get sent, or it maybe run more efficiently in the cloud, for example, some other centralized environment, but a lot of that doesn't happen because it's already happening in the edge. And we are getting to the point, it's like JavaScript, it was very inefficient, but after decades of being stuck with it and having to improve it, I think we are at the point that the gap is narrowing.
I needed that answer. Thank you.
OK, thank you. OK, so thank you, everybody. I will be around if you want to chat. Thank you.